Nadish has explained you guys what AI, Gen AI application building and so on. And he covered most of the theory part and the practical ones using Ballerina integrator. So I'm from micro integrator team, and I'm going to show you how you can build the generative AI applications using our product called micro integrator. So this is the agenda for today. So I'll first give you a brief overview about what Gen AI applications are, and then I'll sort of go through a high-level introduction about micro integrator and explain why you need to use micro integrator for certain types of integration. And then, then we'll go through building Gen AI application using micro integrator. And then I'll again quickly walk you through what is RAG pattern and how we can implement RAG pattern using micro integrator. And then finally, I'll conclude it with agent, and I'll explain how we tackle the problem of agent using micro integrator. Okay, so. Okay, so to start with, you guys now familiar with what are Gen AI applications, because Nadish has explained you. So this is again a quick recap on that. So basically, as Nadish mentioned, the Gen AI models or the large language models was a breakthrough for AI. So using that large language models, if we build applications, so that is what you call generative AI. So if you build those applications, then those applications will be capable of understanding human language, and it can respond in a manner that human can understand in voice, text, or image, or video. So the basic examples are like we can create chatbots and RAG-based applications and agents. So this is the interesting part. I need to discuss how enterprises need to identify where Gen AI applications they need to apply. So basically, if you are in particular enterprise, so you may have written a lot of integrations using, say, micro integrator, Ballerina, or any other language. So that means all the theoretically, so if you can write a program that handles everything theoretically, or you can write an algorithm, you can, if you can write the algorithm for a particular thing, you can deploy it in integration software. But the problem here is like, say, if it text heavy, or if you need a human to do that particular thing, you can't write an algorithm. So that's where this LLM comes into the picture. So for example, you can think of a scenario where, say, if it is a particular mobile carrier network, so if you have any question, you need to call that call center and wait for that particular one to answer. Right? Then that agent will answer your call and ask a lot of details about you to get a personal understanding about you, and then give the particular solution. So under the hood, that particular mobile carrier agent will go through a FAQ guide and particularly track that issue and give you an answer. So that's how basically a human assistant agent would function. So with these LLM applications, now you can do it using integration products. So that's the beauty of using enterprise integration and the Gen AI application. So first thing is like you can analyze a repetitive workflows. And for example, if that particular telecommunication provider needs to have assistants, and they need to go through this same process again and again for whenever the customer calls, they need to go through the same process. That is like, that workflow is repetitive, but it has some human or language or text heavy things. We can't write algorithms. So that is one point where you can use Gen AI applications to improve productivity and so on. And then we have content heavy areas like policy documents. Say, I believe none of you may read policy document when you accept license agreement from start to end. So but the thing is like there might be interesting or critical things inside, hidden inside. So you can get an insight by looking at the particular document. So if AI can help, AI can read through all of that and then give you the important points, then you can agree the policy or license agreement. Likewise, knowledge-based Q&A, all the product, say if it's a product company, you can have all the product details in particular document and create Gen AI applications. And also, as I mentioned in the last analogy, so if it is a particular mobile network helping agent, so that particular agent you need to call and give all your information. So if we can personalize chatbot, so when you're calling from your number, it can get all your details, and that agent knows everything about you, and then they can resolve your problem easily. And so pinpoint the correct areas is the problem now. So because a lot of platforms do support AI application building nowadays. But the thing is like you need to figure out, okay, where I need to put Gen AI applications in my, so we can randomly put AI applications through all the enterprise, but some of them might not need it. So we need to pinpoint exactly what we need to do. Particularly, you need to understand what area that you need to develop these Gen AI applications. And for the tip for identify that use case is like you need to think beyond your current integration flows. So the current integration or any application that you have built for your enterprise, you already know that this thing can be done using, say, a program. So programs do work sequentially or parallelly, but the idea is like it's deterministic. So now we have undeterministic systems like humans, but not accurate at that level at this moment, but it will gradually improve. So then we can integrate that AI applications to your enterprise using our integration platforms. So basically you need to go and see what are the untouched areas in your particular enterprise that you didn't thought that like this particular thing will help because it needs a lot of ambiguity. So you can put Gen AI applications and solve most of the problems. Okay, so since I'm going to demonstrate you on how we can do that Gen AI application building using micro-integrator, I first walk you through what micro-integrator does and how it works. Because some of you might be familiar with it, but I'll quickly explain what micro-integrator product is. So basically, micro-integrator is more than decade-old battle-tested technology that was used to call Enterprise Integration Bus, or ESB. So then it became EIO, Enterprise Integrator, and finally it became micro-integrator. So during that transition period, even though we have a lot of improvements in micro-integrator, it still has this core Synapse runtime. That means that particular Synapse runtime is still there, that battle-tested runtime is still there, and with the new VS Code tool and so on, developer experience is now improved when we compare to Integration Studio that we use to develop integration artifacts for Enterprise Integration Bus. So this micro-integrator can deploy in microservice architecture as well, and also this micro-integrator is basically you have an IDE called VS Code, and in the VS Code IDE we can develop integrations and deploy it to the server using our exportable package called car application, and put it in the server, it will run. So that's the ultimate high-level idea of micro-integrator product. Okay, now let's go through a very simple example first, and then I'll come back to this presentation for RAG pattern and so on. Okay. Yeah. So if you guys are familiar with micro integrator, you might know this IDE. But if not, I'll quickly explain you how it. So basically, you need to install VS Code and install micro integrator plugin on top of that. Then you can create integration projects. So basically, now I have created a sample scenario where I can demonstrate what are the AI capabilities that we can do. So let's start with the simplest one called chat. So basically, it will integrate with large language model, and I'll show you how easy we can integrate to existing micro integrator project. So basically, from micro integrator, if you go to the canvas, so basically this is the service designer that we have for micro integrator. So this particular service will have 3 APIs. So chat API, customer view, and knowledge base. So I have selected the chat API, and there we have 2 resources. So first one is the easiest and the simplest one. I'll walk you through this simple scenario, then you can understand how easy we can integrate AI applications to existing Synapse or the micro integrator flows. So it's in matter of 5 to 10 minutes, you can even add this media and get it working. So first thing you need to, so basically this flow is like, once you get the post request to this particular flow, it will start the mediation. So it will contain a message body, like, so that message will contain the payload and the headers and the variables. So that particular message will flow through this sequence and return back to the client. So it's a data flow model representation we see here. So it's a little bit different from what Nadish showed earlier in Ballerina integrator. So here the predefined data will start from this point and flow through this sequence. So to add AI mediator, I need to click on this plus button, and then also I need to mention that this particular AI is still in beta mode, and we might need some time, like within a couple of months, we'll be able to release it in GA mode, but at the moment it's in beta. So I have added that connector, the snapshot version of it, to my workspace. So once it's released, you can easily go through this and get using that connector from our connector store. Okay. So yeah, so you can download it from here once we do the release. So yeah, until that I'll explain. This is the module for creating AI applications in micro integrator. So we have the basic fundamental building blocks, much simplified, and it's easy to use. So we have created the most important and the components or the building blocks to build AI applications in micro integrator. It's a low-code environment, of course, and then using these building blocks, you can build even complex Gen AI applications. So this particular scenario is using a simple chat operation. So once I add this chat operation to the sequence or the flow, so you will see something like this. So how this chat model need to have a connection. So you can add a connection. So pre-built, we have Anthropic, Mistral AI, OpenAI, DeepSeek, and so on. So later we'll add whatever the all the models will in the GA version. Most of the models will be supported. So yeah, if I add particular connection, then I have that connection to the LLM. So it is represented here as LLM and connection. And you need to select the chat model, and then here is the user query. So basically, I think Nadish has explained what the prompt is and how it's going to the LLM. So basically, this flow will trigger with the user's request, and you can access the request items using payload.query, user query. So here, using this graphical editor, you can browse to the payload and add the user query. Or you can add any message as well if you, so this message will be replaced from the user payload.user query, and it will pass through to the LLM. So if you have sample text here, it will just pass the sample word to the LLM. So if it is dynamic expression, it will get it from the message and send back to the LLM. And the output time, you can select the output time type, and then response of this particular chat operation will be passed down to the next mediator. It's the data flow model. So once this is complete, it will pass to the next mediator. So here what happens is the response is written to AI chat1. This is the variable name. And if I take this particular option, it will replace the message body with the AI result. So otherwise, the message will still be the what user sent to this particular flow. So since this is clicked, it will replace the message body and respond back to the client. So running it from the VS Code itself, we can just click run on the VS Code, and it will boot up a server. Okay, now yeah, we can try out this particular chat operation that I showed you earlier. So here, yeah, in this particular mediator, I type payload.user query. So say user query, and I need to type something here. So let's type, yeah, what are the best thing to do in Barcelona? So if you ask this particular question, it will go through LLM, and simple integration, it will call the configured LLM model and try to get the answer. Yeah, so this is the query that we sent through our request, and this is the response that we got from OpenAI. So Barcelona is a vibrant city, and so on and so forth. What you can do here, so it tries to give you, yeah, whatever the LLM knows, it tries to give you. And the interesting part is like you get all these token counts and output token counts, everything as different headers. Basically, this will be your content. So after this particular mediator, you can add another mediator and get whatever the things you need here to build your integration application. Yeah. So this is how easy you can basically add LLM or intelligence to your existing mediation. So for example, if you have already have enterprise integration build using micro integrator, you can just click of a button, you can add this GenAI capabilities to existing integrations. So that's the beauty of yeah, having this low code and GenAI application capabilities. So yeah, so this is the easiest thing that we can demonstrate, and then we'll go through. So then we need to, of course, go through a RAG scenario to build some complex application. So I think Nadish has explained you guys what a RAG system is. I'll just try to recap you using the simplest possible terms, and I'll try to explain you what is embeddings and how you can, why you need to add embeddings to in your integration flow to get proper answers and so on. So RAG pattern is basically what it translates to is Retrieval-Augmented Generation. So what it does is like LLM is like pre-trained using data in AI factories. Like in OpenAI case, OpenAI will train this data. It's some analogy if you think, say, if we go to school and university, we learn a lot of stuff there, and we remember and we improve our brain to understand things. And then suddenly after, say, 10 years, if you need to do something, say, mathematical equations and so on, if you can't remember, what you do is like, you go and get that book and read, and you can get the context again. Or you can search in the Google and get the context again to remember certain stuff. Because LLMs are also trained in that manner, so during training, it gets to see vast amount of data. So it tunes parameters in that particular black box, and that's how it gives the answers. So it's same as how we study and we train our brains. Then when something, particular instructions we need to pass it through the LLMs. So that's why this RAG pattern is there. So RAG is kind of a database. You can think of it as a database. So you have particular data, like text segments at data. And the problem here is like how to store that data. We need to, again, get it as soon as possible when we need it. But we don't know exactly what data we are looking for. For example, SQL, if you know, so we can add data, and when you are getting it, we need to type that query and get the data back. So in LLM world, we can't do that, unfortunately. We can't get exactly what that data is. So here what happens is like we have another model called embedding model. So we need to, if we have, say in this particular example, I'll try to explain you what it does. So say your company has HR policy, employees can take 21 days leave. So that's the HR policy that the particular organization has. So we need to store this data in the database. So you can think this database as XY pane. So you can store any data in this XY pane, and when you are storing it, you need to get coordinates. So in this example, it's 5 in X and 4 in Y. So in this particular position, this data will, so this is like the high level interpretation, not actually when it comes to the LLMs, it's like multidimensional and very complex. But when you are storing this, what this embedding models does is like it gets this HR, this text segment, and pass through that embedding model, and it will get the coordinates. It will get 5 and 4 as the coordinates. And then it will store in the database under this coordinate, 5 and 4. If you need to get that data again, say employees can take 21 days leave is what we provide. Say now, if we have a query saying how many days of leave that I can take, that's similar matching, but not the exact text. So what happens here is like when you give the second query, it will pass through the same embedding model and give the coordinates very close to this one. So it will be 4.9 and 3.9. So it will land somewhere here. That means it will get this particular data back. So that's why you need embedding model. Like LLM models, we have a different thing called embedding models. In OpenAI and other LLM vendors will provide this particular embedding models as well. So that particular model will get the coordinates when you are storing. When you are getting it back, you need to have, you can give the text again and get the coordinates. I hope this you can understand. If you have any question, I can answer, or I can, okay. So now, why RAG pattern is used, as Nadish mentioned, there are a lot of use cases. So basically, for your organization or any kind of custom data, you can't exactly add all the data to AI. So you need to get whatever the things you need. So to increase accuracy, you need to provide it with more accurate data so that you can get it back. So basically, without RAG or extended data, basically, it's very hard to think of proper AI application. So simply how it works is like, now user input a query. So you can search the relevant documents from that vector database, and with that data query, we send back to the LLM. So LLM can generate a very good output. So yeah. Okay, so I'll explain now, since we know about RAG pattern, I can show you how we can do that in MI. So in MI, if you need to create your own knowledge base or vector database, you can add this operation called add to knowledge, and we have another method called get from knowledge. So I'll explain what this add to knowledge is doing. So if you click at this particular add to knowledge operation, you need to select two connections now. So one is the vector database. So vector database is, you can think of it as a similar to database, and we support out of the box Chroma DB. You can run it, that particular thing in local machine, so you don't need to send data to outside. And this PostgreSQL is also there, and then Pinecone is a SaaS solution for that vector database. So in this particular use case, we are using Pinecone 1. And then for embedding, as I mentioned you earlier, we need to have embedding model to get that coordinates to store in their database. So for that, we are going to use OpenAI's model called so OpenAI model we are going to use for that particular thing. And when you're saving that, whatever the data in the vector database, you need to, of course, give the input. So in, say, for example, if you can pass it from your payload, you can get it from payload.txt and pass to the vector database. Or if you want to get it from a, say, file system, if you have thousands of PDF files, what you can simply do is, like, from MI, you can easily add, say, add artifact and go to event listeners, and you can select file listeners or any inbound endpoint you can select, and basically it will get a similar sequence like this, that file by file you can feed to this particular mediator, and this will get the embeddings and store it in the vector database for you. So once you do that, and once you have the Pinecone vector database with you, now that particular RAG or application, you can simply connect to this one and build the powerful AI applications. So this input part is like what things you are going to give to the vector database or the knowledge base, basically. And then if you need to pass it, you can pass from out of the box parsers that we have. And like in LLM world, we can't store, say, if you have 500 page PDF, we can't store that particular 500 pages in the single vector, so vector database. So here what we are going to do is, like, we need to split it to segments and store it as segments. So there are a few strategies when you are storing your data. You can do it in recursive or paragraph or by sentence. And the max segment size is, like, say, if you have 1,000 or 10,000 size file, you can segment it for, say, small chunks and then save it. So the overlap is like, if you have data chunked on a few size of chunks blocks, you can overlap some content so that it gives more accurate results. And embeddings, of course, as I mentioned you earlier, this particular will run on text embeddings, 3 small model provided by OpenAI. So similarly, you can select whatever the model is supported by this particular language. So, and then here also we have the same design language where the response is again added to a variable. From that variable, you can see what happened to that particular vector knowledge addition operation. And so to try this, since it's running the server, so I can try the knowledge base and try the add to store one. So here is my Pinecone vector database. I'll delete the sample one I have created. So now my Pinecone vector database is WSO2Con 25. It's empty now. So what I'm going to do is, like, I'm going to give content and store it in the vector database. So I have prepared a sample payload. So now I'm going to add this sample FAQ document where I have say it's a FAQ guide where I have my so FAQs, like how do I reset my password. So I have added to reset your password, you need to click forget password and so on. So this particular FAQ document, now I'm going to feed to my knowledge. So yeah, execute. Okay, now this particular document is now added. Oh, I can see the success as the status. So if you go back to the vector database, now you can see this, our document is now added to the vector database using those embeddings and whatever the things I have explained you earlier. So now it has added to the vector database. So that is how easy we can maintain a knowledge base. So basically you need to think of a vector database what suits you best. It's whether it's a SaaS one or the local one. And you can, once you have configured the vector database and you have the embedding model, it's now very easy to you to populate that database using your context. So you can do REST calls and populate your database, or do it in file listener mode or any other mode. Okay, so yeah. Now, if you go back to the get from knowledge base, so basically now we have populated the content to the knowledge base. If we need to get it, so of course in the this operation we can get back the data that we have sent. So here we need to give the same Pinecone or the same vector database and the embedding models. Because to get also we need to have that embedding models, because the text you are going to send to this model will not be the same text. So it need to again using embedding models generate the coordinates and get that data back. So yeah. So now this data, again, the get from knowledge will also get the knowledge back to a variable called get AI get knowledge variable. And here, yeah, you need to, so I have created adding a payload factory mediator. So the payload will be replaced from was.ai.getKnowledge and then payload. So whatever this particular variable returns, I'm going to get it to the payload and respond back to the client. So knowledge bases. So get from knowledge, I'm going to try it. And so here I need to pass text as the payload, and then type, we have added the document, this particular document, and yeah, so I can ask about I forgot the password. So I have not added this particular thing, but I have added the password forget policy, but this is some different text. But let's see how it gets the relevant data from the data what we stored earlier. So you can see that now this is our vector database. So this is our document. Here we have how do I reset password, but the exact text that I sent to the vector database is not there. So it try to match, get that coordinates. So this is, if you can remember what I showed you earlier, it's like the coordinates. So this stuff we don't need to understand or use, but we send it if, say for example, if you need, you can use it. But yeah, this is the text that you get back from the vector database. So it has correctly identified this password related data, and yeah, that particular data is here with the sources. Now if you think about it in the enterprise integrations, if you have certain types of data stored in your database, when it's retrieving back, we now have the sources. We can directly say from this particular PDF file, we got this data, and likewise, we have the references now. So yeah. So this is how you get data back from the vector database. Now if you think about the proper use case, like, so you can't always get data every time you need to do that integration. So for that, we have the thing called rag chat. So rag chat is basically the chat operation that I showed you earlier, the simple one, with the knowledge built in. So here, you don't need to get that vector database data back manually. It will automatically get whatever the data you stored in the vector database. It try to, first what it does is, it try to get the user query or the prompt and search it in the vector database. If you have that data, it will append that data for you and send the chat request. So here here you need to give, again, if it's a chat RAG application, you need to give embedding models because you need to get it from vector database, and the vector database, vector store you need to give, and then finally a LLM connection. And this is the user query that user need to type. So here user query will be user query, then colon, it will replace from the payload dot user query. That means in the payload, if I get send some text in user query, it will create this prompt. And this prompt will search first what we do is we search that in the vector database and append to the context and send everything back to the LLM. So now LLM will know the context by default. So yeah, this one also, yeah. If user query, if I try it out, drag chat, no, here we have the, I forgot my password. What can I do? So here, it's a random thing that I forgot my password that it has in the vector database. So it can get the password recovery policy for you and then respond back using LLM. So you can see here, so once I send this particular thing to LLM, it get the content. So if your password is forget, you can click forget password. This particular thing, it knows from the vector database or the knowledge base. So now you can see the token knowledge, and also you can see the sources. So because we have stored that the document in the vector database, it gives the sources where how it answers that particular question. So here you can see the document is, you can see that document rendered back in the response. So that's how easy we can develop RAG chat operation in micro integrator. Yeah. So then I'll come to agents. Okay. So agent is a somewhat hot topic these days, and yeah, it's like giving the LLM the tools that you need. It's like say if you think of it as a brain. So if it has a brain, now you need to give arms and legs to that, and then it can perform a lot of tasks for you. So LLM is a black box. You can think of it as a black box. It can get the text and output something. But if you give tools, it can perform tasks for you. So agent, to configure an agent, here again you can add it from the tool palette. There's this called agent. Once you add the agent to the flow, for agent to work, you need to have a session or the user ID. For the agent will work on particular task. It will keep memory for you. Like in ChatGPT, you have a set of chat history. Like chat history will have an ID for that particular chat. Likewise, you need to give the user ID and then the chat model, of course, and then system prompt. In the prompt, you can give the instruction for that agent how you need to work. So basically, role and objective. So in this particular sample, what we are going to see here is like, so we have in our office in Sri Lanka, we have something called O2 Cafe. It's a restaurant in the ground floor. So if you think about, for example, restaurant, so if the customer complaints or customer review is received, so this agent will analyze it and try to act on it. So basically, this will read the customer request, and if that particular customer request is, say, the customer feedback is very bad, it will escalate that issue to your manager. If it is a good comment, we stored it in a file system in my folder, so we can refer it later what are the best feedbacks that we got. So it's a simple use case, but I'm trying to show here is like how agents can perform tasks effectively and how easy we can build using this low-code platform. So here you need to first understand what this agent is going to do. It's like if you hire somebody for that particular task, you need to instruct him or her how to work on that particular task. So similarly, you can instruct this AI agent how you need to work on this particular thing. So here I have asked this agent, so you are an AI agent, you need to, your role is to process customer reviews, analyze the sentiment, and extract key insights. And if you have, say, in key insights, if you see slow service or great food, cleanliness issues, what you need to analyze in this particular thing. Similarly, what you instruct your employee to do. So then we ask it to how to act on these issues. So so your goal is to, you need to give goal and the functionality, how particular action you need to take. So if you get a very bad request, bad review, you need to send an email to your manager. If it is good, you need to save that feedback to file system. So to do this task, this agent needs to have email capabilities, and it needs to have file read-write operations. So how we think about this particular thing is like, say now you have a powerful integration platform. So whatever the mediators we have, we can use them as tools for AI. So you used to do integrations, static integrations using this set of mediators. Like say, if you are to do it in manually, you can use this combination of mediators and build powerful integrations. What if we give this capability to AI? It can do the integration task for you. So here in the tools section, you can add whatever the supported mediators by default. So you don't need to do anything. So for example, if you write a class mediator or strict mediator, so say for example, in class mediator, if you write a calculator method that can Java code to do calculations and expose this as a tool, it can do calculations because AI by itself can't do calculations. It is a language model. So if you ask any scientific calculations, it will try to use a tool available by default, but if not, it can't do. That's why if you see 1 + 1, we can trick it and get some different answer because it can't do calculations. So you can write Java class mediator to do calculation and add it as a tool. And also script, you can use JavaScript, TypeScript, or scripting languages and write that particular thing and attach it as a tool. And also you have the luxury of using all our connectors as tools by default. Say if you have Kafka read-write operation, you can give that access to AI. So AI can use Kafka to send messages, get messages, and so on and so forth. Likewise, this file operation, to demonstrate this, I have given this AI agent the capability of writing files. So it can write files and it can send emails. So the configuration of the tools are similar to how we add to the usual integration flow, but there is a small difference here. So if that, say, now if you use this particular email connector in a manual mode, you need to configure everything from what address you are going to send, what is the personal name, and CC, BCC, everything you need to add. Here we can mark AI, so AI can figure out what it needs to send. Say, for example, BCC, if I mark this as agent, so this will figure out this what addresses this need to send email in BCC, blind copy. So this will have all the existing capabilities of adding expressions. So basically, if you type plain text value, so someone at email.com, it will send directly to this email address. If you type it in expression mode and give payload my email, it will get from the message context. And if you click this button, AI will figure out what to do. So that's the only difference when you are configuring existing connectors as tools. Yeah, so we have given these two tools to agent because we have instructed agent to send email if that particular review is bad. If that particular review is good, we need to write it to the file system. So file system, I'm going to write into my local file. So let's see how this works. So yeah, we have it in customer review. So try it. So this will give the user prompt as this is your customer review, and it will replace the payload, and it will get the ID from ID called. So you need to give ID, payload.id, ID, let's give 5 or 3. And then feedback. So this is the restaurant. I'll first try with a nice feedback. Service is awesome. And try to send this one. So yeah, do it. Yeah, this happens. It doesn't need to figure out. Sorry. Right. Sorry. Try it out. Yes. Okay. Okay, sorry for that. Thanks for the help. Okay, so now this, so it has analyzed this particular review. So it's a good review. So review analyze marked as successfully stored in a file because it's a good comment. The feedback indicates positive and send with there's no need of adding. So the file, it gives the file path where it added the review. So it's stored there. So if I go to the connections, my file connection, so in this location, yeah, it has stored. Yeah, 3. So excellent service and actions not required. So then let's try bad review as well. And so this is say food is bad. So I'm demonstrating very simple the terms, but yeah, of course, it can handle more complex because it's powered by LLM. So this negative feedback, so it detected it as a negative feedback, and so what its analysis not successfully stored in file system because that is a bad request, bad feedback. So it sends the email to this email address that I have created. Yeah. So I got this email from the AI agent. So we apologize, this bad behavior happened, and so on and so forth. So you can see how powerful this capability is. When you think about your existing integrations, we have existing running integrations. You can very easily add agents to your flow. So basically, adding an agent is much simplified. You don't need to know about the LLM or AI theories, complicated machine learning, neural networks, or any other things. What you can simply do is like you can add this graphically. It's a low code, and you can simply configure it and try it and see how it behaves. So we can, of course, add AI knowledge or get from knowledge as tools itself. So now it unlocks different kind of agent that is called, it can, now agent have the RAG access. That means in earlier what I showed you is like agents will have a static RAG. That means it will first get the user query and get the knowledge from the LLM and call the LLM. So if you have this get from knowledge as a tool itself, so LLM now can call this vector database once and get the data and do the, say, try to receive an email. It can receive the email. If that particular email has a context that AI don't know, AI can again talk to the vector database and get that data back, and it can do it multiple times. If you have powerful reasoning model, you can build a complex RAG agentic RAG or any kind of agents that can do tasks repetitive. So it can call knowledge base and do another tool call, and that tool call you can again talk to another tool. Likewise, the limits are like extreme. You can, so because we provide the basic fundamental building blocks, from these building blocks you can build powerful Gen AI applications is visually, like in low code. You don't need to go to Python and write a complex LLM application, because if you think about it, it's like enterprise integrator. We were doing this for 15 or more years. So our service is battle tested, and our deployments are running uninterruptedly. And if you build these capabilities to your existing applications, or if you build a new application and deploy it in micro integrator, now you have a powerful but trusted platform to host your LLM applications. So using this, so basically we do a research on, heavy research on what things we can do with LLMs and what enterprise integrated customers need to do with LLMs. So we came up with this after a lot of iterations, we came up with this set of tools as the easiest building blocks possible. So using these combinations of these building blocks, it will unlock whole new level of intelligent applications. So intelligent applications, you can try it, say, for example, in your particular already having integrations, you can add the simple agent to do some feedback analysis or some small stuff and see how it works. Then you can keep on improving that so that you get a very powerful Gen AI application. The easy part here is like you can configure it and run it and see back and forth. So we have some more features like tryout, built-in tryout, but it's again in experimental mode. But once we have that as a available powerful tool, you can try it here itself, and it can graphically show what tools it called and what was the tool response, and so on and so forth. So a lot of things are yet to released in this particular AI module. So yeah, basically that covers what we were doing for MI or micro integrator, what LLM capabilities we were working on for last few years. And so we are now at a state where we have powerful set of capabilities. And also we have AI copilots, some of you might know. So basically this AI copilot, so because now agent is not yet released, this copilot doesn't know about our Gen AI application building tools. So once we do the release, this AI copilot will understand how to create AI agents. So if you think about it, you don't need to know anything. You can ask copilot to generate AI applications, and it will create applications for you. Then you can start it in simple integration and then go along with, because Copilot will understand the context back and forth. You can tweak it and do a lot of stuff there. So we are doing improvements on Copilot to understand these LLM agents and so on. And also we have AI data mapping and so on. And also if you know about our products in our family, like API Manager. API Manager is working on a feature to expose API Manager's APIs as tools. So if you think about it, MI or integration platform can directly call to API Manager and use that APIs as tools here. So if you click the plus button, once you sign into that particular store, you will see all the APIs deployed in API Manager as tools. So, and then IAM is working on, our IAM product is working on giving authenticating backends using for AI, so agents. So agent authentication is coming with our identity provider solution, and we are trying to integrate everything together and build a powerful integration and basically Gen AI app building story. So this particular AI module will soon release within a month. So you can try it out by yourself and, of course, give feedback. And we are improving it very rapidly these days. So also, you can try these particular scenarios. I have added to GitHub. I think Nadish or Shafreen will share the links for you. And this particular example is there in GitHub. You can download and try. So, and also what Nadish has mentioned, that particular thing will also be available in GitHub. So, and the preview version of the Connect is also given there. And also the server release supporting this AI feature is also there in the GitHub repo as developer previews, but not as production ready. You need to wait a couple of weeks to get that. So yeah, I think that covers most of the stuff. So if you get a recap, we have introduced what are Gen AI applications, and we defined how significant are they and how you can use it in enterprise. And then identifying enterprise AI use cases is it's the hardest part, I would say. So you can't just go and do random integrations in AI. So you need to think where I need to put this AI capabilities. So then, yeah, so, and finally, we see how agents, how we can build agents and showcase the practical. So, yeah, so thanks everyone.